Okay, today we're going to get started on section 8.2, and what we're going to start to restrict ourselves to now for the rest of the chapter is just looking at triangles. So in section 1 we talked about any size polygon and what it meant to be similar, and for essentially the rest of the chapter we're just going to focus on triangles. Okay, so we'll start with a postulate that allows us to show that two triangles, again, triangles specifically, are going to be similar to each other. Now please remember, similar means equal angles and proportional sides. Okay? So we're going to look at a variety of ways in which we can prove that triangles are similar to each other. Okay? Now I know that prove word in there makes everybody happy, especially Zoe, because I know you guys just love these kind of proofs. No, I'm just kidding. But we are going to be looking at some of these kind of problems. So the postulate just simply goes like this. It's a very, very easy one. If two angles of one triangle equal two angles of a second triangle, then the triangles are similar to each other. Okay? And once I draw out a little bit of a picture, I hope this kind of feels familiar. So what the postulate is saying is, if two angles of one equal two angles of another, so as an example, if angle A in the left triangle equals angle H in the right triangle, and if angle C in the left triangle equals angle F in the in the right triangle, then the postulate says the two triangles are similar to each other. Well, from way back, we had something called a third angles theorem. And you might recall that, or it might feel a little bit familiar. That one from way back said if two angles of one triangle equal two angles of another, then the third angles are also equal. So for our postulate, if two angles equal two angles, what that then forces is the third angle in the left to be equal to the third angle in the right. And so what we've ended up with then is three angles, right? We have three angles of one equaling three angles of another, right? So therefore, remembering what similar means, equal angles, proportional sides. So equal angles then forces the sides to be proportional. So that means we can create proportions out of the corresponding sides. Okay, so that's the idea. And that's the postulate that we're going to look at here in section 2. Up ahead in section 3, we're going to look at some different ways that we can do that same thing, show that triangles are similar to each other. But this is the one we start with. And we can just abbreviate it. Let me choose a highlighter tool here. We can just simply abbreviate it as AA. If two angles equal two angles, the triangles are similar. Okay, all right. So what I'm going to start with is some practice problems where I'm going to ask you to decide whether two triangles can be made or determined to be similar. So the question will be, determine whether the triangles are similar. All right? And it's just going to be, hopefully this sounds kind of familiar, we've done lots of these this year, it's going to be a yes or no answer. Okay? And since, as of right now, we only have one way to make that determination, AA, we don't need anything further for now. Later on, we'll add the usual step of if you answer yes, then you have to tell me which of the shortcuts we're using. But as of right now, we only have one shortcut, so you don't have to worry about that. Okay, so I'm just going to run through some practice problems. And like always, feel free to put down as many as you wish in your notebook. If you want to skip over one, that's totally fine. Maybe just get a little bit of variety of different types of problems and that sort of thing. Okay? All right, so I'm going to draw them out, and these are just going to be rough pictures, so they won't be perfect, but I hope you kind of get the feel for it. All right, so here's two triangles. Each of them will have a right angle. This triangle has a 43-degree angle. This triangle has a 47-degree angle. And I'll attach some letters here just so we have something to use. So maybe L, M, N, O, P, Q. Just randomly grabbing some letters. And again, the question, can you determine whether these triangles are similar? Okay, so let's give it a try. First of all, we have a 90-degree angle in each triangle. So obviously, we have 1A right off the bat. Okay, then the issue, the other angle we're given in the left triangle is 43, and in the right triangle is 47. The first thought might be, well, those angles are not equal to each other. Obviously, 43 and 47 aren't the same. So first instinct is to say, no, the second angles aren't equal. But because you guys know how to find the third angle of a triangle whenever you know 2, maybe we can change our answer. So can you find this third angle and this third angle when we know 2 out of the 3? Of course, because they add up to 180 degrees. So if one angle is 90 and one angle is 43, the other angle is 47. And now you can see how it's setting you up. All right, and I'll just follow through. In the right triangle, if one angle is 90 and one is 47, the other one therefore has to be 43. Because once again, they have to add up to 180 degrees. And now it's clear that we have oops, sorry, I chose the wrong tool there. I meant to choose a highlighter. There we go. So obviously now we have a second angle, and in fact, even more, we actually have a third angle as well. We don't really need the third, we only need to get to the second. So obviously we have 2 A's, and therefore the overall answer would be yes, these two triangles are similar to each other. And if anybody's interested, the similarity statement, we could pick the letters from the left triangle in any old order. I'll just go alphabetical. And then that would be similar to the right triangle, but we have to make sure that we match up equal angles. I started with angle L in the left, which is 47. So I have to start with 47 in the right, which is at Q. Then I went to M, which is the 90. In the right triangle, the 90 is at P. And then I finished with the 43, which is at N, and in the right triangle, the 43 is located at O. So the correct similarity statement, if anyone wants to practice, would be that. Okay? So there's one kind of problem we could give you, right? There's one kind. Excuse me. Like always, feel free to pause the video if I'm moving too fast for anyone. Okay, but otherwise I'm just going to move on to a second example. And it's going to look very similar. Once again, just try to draw a decent picture there and there. And again, just kind of randomly attaching some letters here. So maybe T, U, V, W, X, Y in whatever order, doesn't matter. And then I'm going to give you some info here. I'll tell you this angle is 85 and this angle is 45. And then in this triangle, 85, and this angle is 50. Okay? So with that information, again, can you determine whether the triangles are similar to each other or not? All right, and you might think, well, this is just that same thing you did on the previous problem. He gave us one, obviously, that is the same, 85 and 85, which of course gives us an A. The other two are not equal, 45 and 50, obviously not the same. So maybe he just, once again, tried to sneak in with that third angle. Well, you guys are capable of finding that third angle. So in the left triangle, when we have an 85 and a 45, that means the third angle would then have to be, what is that, guys? That's 120, 130, so that would be 50. And then, obviously, we're in good shape because then I don't even have to go any further. We can actually stop this time. And we can see that the second angles, oops, hit the wrong color. There we go. The second angles then are equal. Okay, and we're all set to go. We're all set. All right, so not too bad there. Oh, I'm sorry, I forgot to write out, yes, the triangles are similar to each other. Okay, let me try giving you some different information on these last couple. So here's a third example, and maybe I'll try using this tool to see if it works okay. So I'll draw you a big triangle. Yeah, that worked out okay. And then I'm gonna put in, whoops, come on. Put in a line here. All right, pretend that's straight. And once again, just kind of attaching a bunch of letters here just so we have something to work with. A, B, C, D, E. And then, oops, didn't make that look good. Then what I'm gonna tell you is that BD and AE are parallel to each other. Okay? Now I'll be more specific on this one. The yes, no, what I'm actually asking on this one is, would triangle ACE, the big triangle, be similar to triangle BCD, the smaller triangle? I wanted to be more specific so everybody knew exactly what triangles I was talking about. So I'll put a question mark on the end of that. Are those actually similar to each other? Okay, well, our only shortcut again is AA. So we'd have to show that two angles of each triangle are equal. Okay, so can we get there? Well, we have a very, very easy one to start. We know that the angle at C in the big triangle is going to be equal to angle C in the smaller triangle because they're the same angle, the exact same angle, right? And also notice just in the similarity statement that I'm asking you about, notice C is in the middle of each triangle expression. Okay, so we know then that angle C in the big is equal to angle C in the small. So for sure, we have 1A. Can we get to a second A? Well, there's no numbers given for the measures. There's no other tick marks that help us out. But what we are told is that the two lines are parallel to each other. BD, AE are parallel. And so the challenge is, we're asking you to remember from the old days, way back in the fall, that if we have two parallel lines cut by a third, called a transversal, then angles in the same relative position, like this one and this one, are always going to be equal to each other. Those kind of angles are called corresponding. Okay? We proved that back in the fall. So if we have two parallel lines cut by a transversal, then the corresponding angle at B and the corresponding angle at A are going to be equal to each other. And that gives you a second angle. Right? And of course, that's all the further we need to go. And so therefore we can answer yes because we have two A's. Now, if anybody's curious, we could have used exactly the same logic to say the angle at D and the angle at E are also equal. Exactly the same logic and reasons. But either way, we get to at least two A's, actually all three if you want to. So our overall answer once again is yes. Okay? And I've got one more yes-no question to go through. And again, slightly different information. I've got to, let's see, I think this is the fourth one I did. And this one I think I have to do freehand. I don't think my iPad will help me with this one. All right, that's not terrible. And I'm going to attach some letters. I always forget where I leave off, so I'll just start wherever. So D, F, G, and H. Okay, and once again, the information I'm going to give you involves parallel lines, so I'm going to give you that line is parallel to that one. Okay, now I think it's pretty obvious which triangles we're talking about here that we're asking, can you show these are similar to each other? Okay, all right, so let's give it a try. can we get to the point where we can say two triangles are similar to each other, right? So we have to look around for equal angles, and the way the picture is drawn, the way the triangles are laying out, can we determine if any angles are equal? Okay. And what we could start with right away is the two angles at F, the one kind of pointing left and the one pointing right. We actually know those are going to be equal to each other, so of course that's going to give us a. And we know those are equal because those two angles are vertical angles, right? Two straight lines intersect, the opposite angles are equal. So we know those two vertical angles are equal. So for sure we have one A. Can we get to a second A? Well, once again, the other information we're given is that the two kind of the vertical lines are parallel to each other. And once again, we have a theorem from way back that says if we have two parallel lines and we're cut by a transversal, the alternate interior angles are equal. So this angle and this angle are going to be equal to each other. Those again are called alternate interior angles. So therefore, back up to our picture, we can then determine that the angle at D and the angle at H are going to be equal to each other because the parallel lines cut by a transversal, the alternate interior angles are the same. And that gives us, once again, a second A. So we can stop right there. We don't have to do anything else. And the overall answer is yes, the triangles are going to be similar. Okay? Again, if anybody's curious, we could have extended that logic and once again shown that the angle at E and the angle at G are also equal. Same logic. Okay? So that actually would give us a third A if you wanted it. And one last time, just for practice, if anyone needs the practice, we could write a similarity statement by taking the vertices for the triangle on the left and put them down in any old order you want. So I'll just randomly pick DFE. And then when you write down the vertices for the second triangle, you just have to make sure they match up. D has 2 tick marks, H has 2 tick marks, so those each have to go first. F has 1 tick mark, F has 1 tick mark, that has to go second. E has 3 tick marks, G has 3 tick marks, those have to go third. So if anyone just needed a little bit of practice, that would be the similarity statement. Okay? And then finally, the last thing, just on these last 2 problems, I'm going to get away from the yes, no questions and switch up to talking about sides. All right, switch up and talk about sides a little bit. Okay, so what I'm going to ask you to do is on these, I'm going to ask you to find, my iPad's jumping around, find the missing sides of the triangles. Okay? All right, so I'm going to try drawing out a couple of triangles, and I think to finish this video I'm going to try to do 2 of these folks. So here's my first triangle, and then here's my second triangle. And before I attach any sides to the picture, I just want to give you some information about the angles. And before I confuse anybody with the sides, I just want you to clearly, see that it's pretty clear we have 2 angles of one triangle equaling 2 angles of another triangle. So therefore the triangles are similar. Okie dokie. All right, then I'm going to attach the sides to each. So let's see here. We're going to have let's see, these are going to be, this one is 4. This one is 6. And then this, oh no, I put the 6 in the wrong spot. This one was 6. And then this one was my 8. Did I do that one right? Yeah. And then my other triangle, I can't read that. So let's see, I gotta just look that one up. So let's see. This triangle, oh, there it is. So this one is 6. And then I'm going to ask you to find this side and that side. There we go. There we go. That looks right. Okay. So how do we find missing sides or missing pieces of similar triangles? Well, once again, we know that the two triangles are similar to each other because we know two angles of each are equal. And then I need you to now remember the second part, which is if we have similar triangles, then the sides are proportional. Now, what that means for us is that we can set up a 3-part proportion, right? And what we mean by 3 parts is 3 fractions. Because triangles have 3 sides, we can set up 3 fractions. And what we do is we take the sides off one triangle or the other, doesn't matter which. So I'll just grab the sides for the left triangle and put them down in any old order you want. So I'll just go 4, 6, 8. Now what we have to do is match up those sides with the corresponding sides from the right triangle. And this is when we have to look across from equal angles. As an example, the 4 is across from the angle with 2 tick marks on the left, and across from 2 tick marks in the right is a 6. Across from 1 tick mark in the left triangle is a 6. Across from 1 tick mark in the right triangle is an A. Oops, sorry, that's a terrible A. Try that again. And then finally, across from the angle that doesn't have any tick marks, so our third angle is an 8. And across from the third angle with no tick marks in the right triangle is a B. Okay, so we have a 3-part proportion. And then what I want you to do is cover up one of these at a time and cross multiply with the other 2. So I'm going to choose my little hand icon. So pretend I'm covering up this one, or covering up this one, or covering up this one. And what we're going to do is cross multiply with the other 2. Okay? All right, which is the only fraction I'm not allowed to cover up right off the bat? Well, it'd be this one. I can't cover up the first one, because if I cover up the first one, I'd be cross multiplying and dividing here, and I'd end up with one equation with 2 variables. So instead, what I need to do is cover up maybe like the third one, because if I cover up the third fraction and now cross multiply, go in this direction, I'd have 4 times A, and go in this direction, I'd have 6 times 6. Giving me obviously an equation with 1 variable, so I can easily solve this, dividing both sides by 4. So the value for A must be 9. Okay? And then I can move over and cover up the fraction that's in the middle, cover up the fraction in the middle, and if I cross multiply, I'll just choose a different color. If I cross multiply this way, I'd have 4 times B, and if I cross multiply this way, I'd have 6 times 8. Okay? Once again, giving me a very easy equation to solve. Divide both sides by 4. So B is equal to 12. And we have our 2 missing sides. All right? Our 2 missing sides for that triangle. Right? Look okay? Look okay? All right. I was thinking about doing 2 of those, but I'm looking at the time and I've been going for quite a while, so I think I'll pause it there. And then when I come back tomorrow, I'll do a few more numerical problems, and then we have one other that we have to do as well, so we'll have like 4 problems that we need to take care of tomorrow. Okay, so this assignment will then be due on Thursday. Okay, so I hope everybody's having a good day, and we'll talk to you tomorrow.